Thank you very much for coming oh, no, not mine, our presentations. Yeah. So let's start about civil infrastructure platform set of industrial grade Linux. And yes, before beginning our talk, let's introduce ourselves. Yes, start.
Yeah, thanks everyone for joining this session. So myself Dinesh, primarily. Okay. So primarily I work for CIP Security Work Group activities, and of course we apply these security work group activities and CIP activities to our Toshiba internal products. So today we will look into some details overall about CIP current states from different work groups and some details about security work group. Yeah, so yes.
Okay. And my name is Yoshitake Kobayashi. Actually, I'm working for Toshiba, but today I have a heart for CIP. I'm leading a CIP project as a TSC chair. So thank you very much. And this is the agenda. And okay, let me try to my best when I finish my presentation in 15 minutes because I have 60 slides for this. So let's try. So that's why I said quick updates for that. All right, and CIP is a Linux Foundation project. So I think this we can say we are a very conservative project, but I'm sure that is a very important project for our society. And many members joined currently, but if you want to help us or help whole society, please consider to join. And tomorrow we have CIP mini summit. And before coming here, maybe you can still add CIP mini summit in your options. So yeah, please join that. So now let's start introducing CIP. And so please look around. You can see electricities, or when you come here, maybe you will use trains. Yes. So please consider that kind of systems now running on Linux. That's true. But think about the life cycle for the products. So this is a kernel usage for many products. And the orange color is the release year for each kernel. Then we have development time and start blue or green lines. That is the actual expected life cycle for products. That's quite long, sometimes more than 20 years. So, but during this phase, now we should consider about the security. This is a kind of static 6. And let's see the right side for the graph. It goes quite fast to grow, nearly doubled each year. So to solve, we have to consider about apply IoT concept to industrial systems. That requires very long life cycle with security. To ensure that comes requirement, we should consider about industrial gradeness, which include reliability, functional safety, and also real-time capabilities, and also sustainability for long life projects. Then security we should also consider about that. So to solve these kind of issues, we established the CIP project. Our goal to establish an open source base layer for industrial grade software to enable to use implementation of software building blocks for civil infrastructure systems. And the most important concept from our side is open source base layer. So let's look at this figure. We have a CIP kernel, that is exactly Linux kernel. And then to build embedded systems, we need to have some essential components. For example, CIBs or some shell command lines or something like that. So we said that kind of is fundamental packages, CIP or packages. And on top of that, any users able to create their own images by using additional packages. This is a concept of CIP base layer. And to adapt to use a CIP base layer for your products, you can just use CIP kernel and CIP core packages. And on top of that, you can also use Debian or Yocto, whatever you want. But if you are using CIP base layer, you can reduce 70% activity for your products. Sorry, I mean just say Japanese 7. So this is quite huge effort. You can reduce it when you use CIP base layer. And nowadays, we are focusing on some activities that are colored from 1 to 6, and that includes CIP long-term support kernels that runs by CIP kernel team, and for CIP core packages, and also to create reference images, so our CIP core working group run these activities. Then we combined of CIP kernel and CIP core packages for testing, and testing work group responsible for all testing activities. And security is also important, not just fixing vulnerabilities, but also we have secure product development process or secure frameworks. So that is responsible by security working group. And today we have a future talk from Dinesh. And also updating is important. So these 5 activities are run by CIP working groups. To work with inside the CIP, we don't consider we can do it by ourselves only. We should collaborate with upstream projects. There are many kinds of projects focusing on each main some critical issues. So if we find some project, we should contribute to them. Then use it inside the CIP to create open source base layer. This upstream first principle is very important, and we are every time considering about that. Now let's dive into the actual activities. And the first activity is CIP kernel team. And kernel team responsible to maintain CIP kernels more than 10 plus years. And they are monitoring all vulnerabilities. And also sometimes we find upstream patches. We also contribute to the upstream LTS activities. And all staffs managed by CIP kernel team. And let's look at some numbers here. So we are currently have 5 versions of CIP SLTS kernel with 4 architecture support, include x86, ARM7, ARM8, and RISC-V. And this is a timeline. Let's see. We started at 4.4, and it's already end of life in the upstream long-term support. So we are not taking over, but some kind of taking over with limited support scopes, and currently maintained by ourselves. So during the long-term support period, we should work with LTS projects. And this is a release cadence. So once we release latest one, the release cadence is also reduced because there is some statistics. Maybe older kernel have smaller patches. So that's why. And this is a kind rest of our reference board, we tested CIP kernels on this listed reference board. And recently, TI M62P was added as a reference hardware. And this board already fully supported in Linux 6.12 with a U-boot. So they are also working to upstream some modules, but they already posted. So we'll see they also backported to the CIP kernel for the long-term support. And the other stuff is reviewing. So reviewing patch is important. So we contribute to the LTS. So all LTS patches are reviewed by our CIP maintenance. And also sometimes we find some issues. Of course, we are reporting to the upstream maintenance. And recently, we reviewing lots of patches per month, approx 1,000 patches per month, something like that. This is a kind of number for what we are doing. And to reduce our effort as much as possible, we also automate it by using some tools. And this kind of tools also you can download and test it. But most important is what we are doing now. So let's see this graph. Too small, but the most important part is color. yeah. For the blue part, it comes from LTS upstream stable, and orange part we are doing by ourselves. So let's see 4.4. During the LTS support period, it's actually from CIP 30, but we started CIP 3 or something. You can see not many patches on top of the LTS. So this is our upstream first policy. And then LTS is finished, we should backport ourselves. So that's all CIP patches. So during the LTS period, the average of number of packet patches is around 2030. And after LTS period finish, the number of patches are reduced because we are most stable, I think. Yeah, the other patches also have similar things, I can say. So from 4.4 230 and 4.90, 250, and 510, 350, and 6.1 around 500. Then latest one is average is 550. So it's increasing, but when we maintain a long time, it's decreasing. So this is a kind of statistics what we are doing. And from now, CIP core maintain Debian-based CIP core packages. So we worked with Debian for a long time because they are providing ALTS to up to 10-year support. So we joined these activities to ensure our support period. And also we worked with reproducibility. And now all CIP images reproducible. So all patches required for reproducibility, we already upstreamed. And then let's move to software update. We have activities for software update with tough integrations and also a delta update or something like that. And the latest status is we supported a delta update and with tough integrations. So now we have two kinds of delta updates. One for root file system, the other one for kernel. And all this kind of testing also are tested in CI. So that is what we are doing. Now that means all CIP kernel with CIP core reference image can be supported, can be tested automatically. So this is the latest status, and unfortunately the booth is closed. But we had a booth here, and yeah, if you already go there, you may find software update demonstrations. So that's all my part, and I did 50 minutes 30 seconds. Well done.
Thank
Right. Take opportunity, Dinesh.
Yeah, thank you, Siran. Yeah, so basically during this demo, we have shown the support, how we integrated WFX and TUF, and we have basically certain use cases which we implemented. So the details are already available in CIP Playground GitLab repository. So those links are available as reference here. So I will now only focus on security workgroup activities. So yeah, just to set context, as we see advancements in technologies and different factors, because of that, basically we see more and more connected devices and more advanced technologies which are making attacks and cyber incidents much more easier. So we have to also work towards mitigating those kind of attacks and incidences and harden our images and work to achieve the goals where our components and software remain secure. So, sorry. Yeah, so in that direction, basically there are 5 important cyber security pillars. We keep talking about them. And these pillars, basically to achieve those important cyber security components, there are multiple things which we do, like integrity, confidentiality, availability, and authenticity. So basically, these things are combined in many security compliance, which we will look into IEC details. So by applying these components in our components, we can make sure our components have these properties, characteristics where integrity is maintained, confidentiality is maintained, component or overall software availability is maintained. So yeah, let's see into detail. So basically, because 4-1 updates were provided in previous OSS event, so this presentation focuses more on 4-2 details. So 4-2 is more about adding capabilities in the components, and it basically focuses on identity access management, privileged access management, and cryptography. So yeah, just saying cryptography means much more detail is there in coming slides. And vulnerability management, regular monitoring stuff. So how we do that, how do we achieve that? So those parts have been basically mostly already achieved, and we have been basically audited by compliance body. So those details are also published and available for all the CIP users. So as we can see, until we make individual components of entire system secure, our total system or subsystems cannot be secure. So 4-1 and 4-2 basically focuses on individual components, and they are categorized in four ways, like application, embedded network, and host devices. So for CIP, because it's a platform, so we focused on embedded and network categories. And those requirements have been basically verified for CIP. And then by reusing those compliant components, system integrators and asset owners can build complete products. So we will see more detail about now individual component details. So basically, while starting the IEC compliance activities, so there were certain goals. So our goal was to achieve security level 2. So there are total 4 security level, but security level 1 and 2 covers most of the requirements of IC. And two device categories, networking and embedded category. And we have used basically CIP kernel 6.1 and is a CIP core release v1.6. Now the release is 1.8 already out. And the reference device for this assessment was used Siemens device based on x86 platform. And yeah, the details are already available here. So this 4-1 compliance results, basically this was completed last year, and here we can see close to 80% secure development practices which we follow as part of course open source model and open source development practices. So we basically work to investigate and try to map those requirements for 4-1 to CIP development practices. But still there were a few practices which we cannot meet in CIP because very specific to end product and use cases. So apart from that, all the remaining requirements, which is close to 80%, they have been basically confirmed by the compliance body, and those kind of audits were done. And we have created guidelines and documents available in GitLab. For 4-2, basically this just shows the overall percentage for different security level, how many percentage of requirements are there in 4-2. So for security level 1 and 2, basically if you see, it covers more than 80% requirements. If we achieve security level 1 and 2 for any components, it means we meet more than 80% requirements. Remaining requirements for security level 3 and 4, they require specific hardware features and very specific use cases. So that is why in CIP we decided to go for security level 2. And as you know, in CIP we follow a democratic model where all the CIP members collaborate and we make some decisions whether to decide a specific security level or whether to decide which device to go for the compliance, or such kind of decisions are taken in TSC meetings. So current status is basically for SBV1 testing is about to complete. Just few requirements are currently open and we are working to close them as soon as possible. And then in parallel, we have also started working on SBV2 testing, which is threat modeling testing. So we have created threat model for CIP development and MCOM device overall. And that is currently internally under review. And this, we will be initiating the mitigation testing for threat, identified threats, and those details will be published. So these results basically can be used to apply in the end product. And SVV3 and SVV4 testing focuses more on penetration and vulnerability testing. So we will be doing SVV3 and SVV4 in coming months. And yeah, we are expecting to finish them maybe in next 3 to 4 months, all this testing, and publish the results. This is more detailed about the 4-2 assessment results so far. So as I said, just 5 requirements are currently open for 4-2 SVV1 testing. All others are completed. So here is the detail. So basically there are 7 foundational requirements in 4-2. So here are the details. Here the meaning of pass means in CIP those requirements we can meet, whereas NA means those requirements are not applicable to CIP because of multiple reasons. So majority of the regions listed here, like they requires additional application support, like application has to configure certain security policies which should be enforced by platform, or there are very specific to use cases which we don't have in a CIP as platform. They depend upon business requirements, and few requirements which are hardware specific, which require hardware specific features like networking device, they require specific hardware features. So those requirements become NA in CIP assessment, and they should be met by CIP users basically. But for the requirements which are NA, we provide detailed document and guidelines based on our discussion, which we has worked with the compliance body, so that it will be much more easier to fill those gaps and apply these things to CIP-based end products. So as we see, just by meeting security level 1 and security level 2 requirements, majority of the 4-2 requirements and compliance is covered. And that is why the overall effort, which it seems it can reduce drastically, close to 60 to 70%. And that is why reusing CIP as a base platform and building up on top of this will help to definitely achieve IC compliance. And again, like there are new security compliances coming, and it will also help us to bring closer to meet gaps if we want to go for CRA or other security compliance. So definitely all these requirements which are basically in IC, so similar requirements are also applicable to other security compliance. So yeah, this is a step in that direction, we can say. So we have created we can see in this GitLab repository, there are many guideline documents which can be used to fill the gaps which are for not applicable requirements in CIP. Okay, so some of the important topics which we found during 4-2 assessment was related to like defining essential function, identifying the essential function, and PKI capabilities and threat modeling. So just some few quick updates. So essential function is nothing but we have to identify what is the bare minimum essential function of the component, which should be always available irrespective of the condition, like any security incidents happens or any incidents which may break the functioning of the system, but still the essential function should be available. That is the basic requirement of IEC standard. So we need to identify, like component owners need to identify that kind of essential function. So for CIP, we identified these listed essential functions related to audit logs and networking services. And then we also need to provide the steps how this can be verified. Like we need to simulate a certain environment by creating, let's say, DOS events, and then basically ensure that the essential function remains available. So this was already verified and confirmed by compliance body. So yeah, this can be followed by component owners. For PKI capabilities, because OpenSSL 3.0 already supported in CIP, so there were few requirements in IEC which require some additional capabilities like certificate enrollment, digital signature verification, certificate renewal. So we can use OpenSSL client, which is already part of OpenSSL 3.0, and it has many capabilities, but still to automate the entire process or to add additional capabilities, we have to rely on certain other components. So this CMP client is one of the important components. So we have to do this setup as part of IC assessment, where we did a setup of separate CA server to verify these operations like rigging, certificate revocation, these things. So in future, the plan is to integrate this kind of CMP client as part of ESA CIP core. So this becomes more complete solution. Anyone can reuse that. So yeah, currently these components exist separately. They are still not part of ESA CIP core, but in future there is a possibility we may integrate these components in ESA CIP core. Okay, so it brings us to the conclusion. So basically, yeah, in conclusion, we can say, because there are a lot of things to do, whether it's security or maintenance or lot of other things. So yeah, collaborating and working together will help all the companies, all the organizations to like overcome these kind of challenges. And as CIP is already doing this kind of effort, and member companies and CIP users are benefiting because of that. So yeah, that will be helpful. You also understand and try to use this, contribute, and work together as community. Yeah, so that's all. Thank you.
So,
Okay.
questions? Question?
Just really short one questions. I asked previous years if, for example, NXP shows some interest in being the member of the CIP. I guess not, right? Just the question if NXP just shows some interest in membership.
Thank you. Yeah, that's good news. Any other questions?
It's also if they have.
If they-
Did they come?
Oh, they said so. No, no. No. I think we talked sometime. Yeah, but ongoing, I hope.
But I guess NXP must answer if they are showing interest in being part of the CIP core.
Yeah. So, any other questions? All right.
Yeah, let me ask maybe a stupid or trivial question about the super long-term support in the kernel. Will you be picking up basically just the patches that are splitted against the current long-term support lines, or can you detail the process a little bit more on how you're providing this SLTS? So what kind of patches do you include and so on?
Rich? Yeah.
I think I can answer this one. So basically, we are watching the oldest LTS that's still still maintained, and if the patch looks applicable and so on, then we apply it.
So applicable, and if it's not applicable because it's just what you're not having the defect, or what is not applicable? Do you mean applicable as git apply will work, or what is not applicable?
Okay, so if git apply will work, then we will generally take it, and if git apply will not work, then we will like do some investigation if it should be like it's more URI's tasks now, but we will generally investigate if it should be modified to be applied or if we can just ignore it.
If you want to. Okay. Yeah.
So, but maybe to add on top, the other aspect for us is the kernel configuration that is in scope for CIP. So we will not look at non-applicable S390 patches because that architecture is not in scope for CIP. So we are not taking randomly stuff. We actually took some patches, I think, from alien arch or alien corners of the kernel, but they applied and someone actually asked actively for that. But CIP is not committing on the other part. So this is another area that we include in the review process and the inclusion process if things become complicated, because we have to manage the workload on that.
So if I understand it correctly, then you are checking for changes on what is relevant based on the config. You say you will support and take all these patches. It's not like that you're checking for CVEs, where you then get the information, okay, there's a CVE, which I now need to patch.
Maybe we should move closer.
Yes, so basically these days CVEs are generated from the stable. CVEs are same different number for C as for stable hashes. So we will watch that we work with the hashes, not with the CVE numbers, but it's the same. So basically these days, if you have a stable kernel commit, and it's not like a trivial change, like changing comment, which shouldn't be there anyway, but it sometimes is, then it gets CVE number 2. So you have two identifiers for the same patch. You have git hash and you have CVE number. And we watch the git hash move through the stable kernels, and if it reaches like 5.10 at this moment, I believe, 5.4, then we will consider moving it down to our like 4.19 kernel.
Thank you.
Do you expect the EU Cyber Resilience Act to have any major impact on maintaining the SLTS kernel in any way?
Just in my opinion, it's impact for us, but we do right thing. Yeah.
CRA is saying that if there is another regulation, then CRA is not applicable because they are using 62443. It's not applicable.
Any other questions? All right.
I would have one more question regarding the kernel. I guess currently, if you're taking the 5.10 kernel, it's rather easy to check for patches which are in the stable one. But if you now think of 8 years in the future, if the kernel differs way more, and you will find there is a CVE in the mainline kernel in 10 years, what is your strategy to identify if the current kernel or the kernel you support, the super long-term support one, is affected? And what is then your strategy to fix this?
So we are watching, so forget term CVEs, it doesn't mean anything anymore. If there's a serious security vulnerability we care about, we will investigate and use like our human brains to try to decide what goes on. Previously it happened, you may have heard about the Spectre series. It's still continuing, so the CPUs are bad and so on. And in some cases we just decide to document that. So for example, our 4.4 kernel will have a note that says that these Spectre attacks are basically not mitigated because we don't care that much, we don't run the hardware, and like threat model is different and patches would be way too hard to backport. So if we something serious security related, then we do investigation and either we fix it or we document that it's not fixed.
How do you define serious in this context?
Well, question was how do you define serious security problem? Our definition is probably different from what the CVE are assigned for, and it's like so first we will need to define threat models, what we care about, because for different use cases, different threats are serious, and currently we are just assessing it ourselves, and we will probably need to document it more. But
how are you assessing it? I mean, is it just your gut feeling? Or
yes, I have a chicken, and I ask the chicken, does it look serious to you? Yes, this is a serious one.
Yeah. Thank you. I think it's almost time. So yeah, I finished. And thank you very much. And please consider to join CIP project. And there are many resources available. Okay. Thank you very much for your time. And now you are going to closing game. Thank you.